Hey guys, in this video we are going to go over the quotient law of exponents. Okay, so with quotient law basically means fraction, right? So when you have a fraction looking thing or a fraction looking problem and you see that there's exponents involved and you have to simplify, what I think of is where are there more of, and you use subtract. So with the quotient law, you basically subtract the exponents to each other, and I like to use this easy rule of like where are there more, and that's where they stay. So I'll kind of go into that. Now here, you want to look at your like bases and you want to look at it part by part. So let's just pretend like that bottom part isn't even there, right? So let's pretend like this bottom part isn't there. Can I simplify this? No, right? Because there's nothing I can combine with each other. They're nothing alike with each other, right? No like bases. Here, I can't combine anything either. So then you start and you go across the fraction bar here. Now here you have like bases of 4 and 10. Well, you would do 4 divided by 10 because this is a division bar. Well, 4 divided by 10, okay, if I simplify that fraction, it actually becomes 2/5. Now, if you don't have a graphing calculator at home, if you don't have a graphing calculator at home, you can actually do 4 divided by 10 in Desmos. And if you want it to give to you as a fraction, you see the little blue area, you hit on that fraction, and it gives you 2/5. And if you want it as a decimal, you just get rid of that. So it tells you 2/5, and it simplifies it for you. Okay, moving back. So that simplifies our fraction. Now we're going to look at the next base that we have in common. Here I see x cubed and x. So again, you can only combine things that are like bases. Now the x in the bottom has an exponent of 1. So here's the game I play. Where are there more x's? There are more x's in the top, correct? There's 3 in the top and there's 1 in the denominator, right? There's 3 in the numerator, 1 in the denominator. So there's more in the top, so that's where they're going to be. That's why I put an x there. How many more? What's 3 minus 1? 2. Easy, right? Subtract. Okay, the next base I see is y. Y to the 6 and y squared. Where are there more y's? The top, so that's where they're going to be. How many more? Well, 6 minus 2 is 4. Moving on. The next base I see is z's, right? Where are there more z's? In the denominator, in the bottom. So z goes in the bottom. How many more? There's 3 more. And that's it. So you don't want to overthink this too much. I like to play, hey, where are there more of them? Now, you can do it a little bit more of a complicated way, but I just prefer for you to think about it in the simplest way as possible. Okay, moving on to the second example. Okay, here, just like I said, you want to split it into parts before you move on. In the numerator, before I even go, I notice that I can simplify something. I notice that I have like bases in the numerator. I have x squared and x cubed. I want to combine those. The question is, do I add 2 and 3 or multiply 2 and 3? Okay, here I would add. The only time you would multiply exponents is if you're distributing, right? If there's parentheses and you're distributing. So this would be x to the 5th. 2 plus 3 is 5. And then I would just have y to the 4th. Okay, now moving on, I notice that in the denominator, I can simplify this guy over here. Well, how do I get rid of parentheses? Well, I distribute, right? Distribute. And distributing is the operation of multiplication. So the y squared in the front is going to stay exactly the same, right? The y squared is exactly the same. But here I'm going to have x, and then 3 times 2 is 6. Now, do I have to write the multiplication sign in between these? No, I don't have to. I know that they're being multiplied to each other. Now, you can only combine things that are like bases. So, for example, I see that the x's here are in common. So I can simplify this fraction for sure. They got to think about where are there more x's. When you have a division bar, you want to think about which side is there more on, right? So now you think about sides. Where are there more x's in this problem? There's more in the denominator. How many more? There's 1 more. Now, you don't have to write the 1 if you don't want to, but if it helps you, that's fine. Now, the next thing is I see like bases of y. We have y to the 4th in the numerator and y to the 2nd in the denominator, okay? Where are there more y's? There's more y's in the numerator. How many more? There's 2 more, right? 4 minus 2 is 2. Can I simplify this any further? Nope. So I am done with that problem. Number 3, now here I notice, whoa, there's a lot of stuff going on. There's a fraction inside, there's a bunch of stuff in that denominator, and it's parentheses squared. Okay, you want to think of things one step at a time. So the first thing I'm going to do is look at the numerator. Nothing I can simplify here, so I'm going to move on to the denominator. There's some stuff I can simplify here. So I'm going to leave the 3x squared 3x to the 4th exactly how it is. I notice I have 3 and 2 that are like bases, so that would be 6, 3 times 2. And then I notice that I have x and x. Now these are both to the power of 1. And I would add them because I'm not distributing anything. So it'd be 1 plus 1, which is 2. And the y to the 5th, because it doesn't have anything else to connect to or to combine with, it's just going to stay. And then I have everything raised to the squared. Before I even want to distribute that exponent on the outside, I want to simplify this fraction first. So the first thing I notice is I can simplify 3 divided by 6. 3 divided by 6 is 1/2. Okay, 1/2. 3 divided by 6. You can type that in Desmos and it will simplify for you. The next thing I notice is I do have common bases of x. Now I have x to the 4th in the numerator, x to the 2nd in the denominator. Where are there more x's? In the top, in the numerator. How many more? 2 more. Now the y here. Are there y's on the both top and bottom? No, so it actually just stays in the denominator down here. Now, I don't have to write the 1 in the front of the x squared because it's honestly just a waste of space, but you can write it if you'd like to. I still have this squared, though, that I haven't messed with. And when I have parentheses, I have to distribute it to every base, and here I have 3. So the first thing I distribute it to is going to be that x here. It's going to be 2 times 2. You're distributing, right? It's the operation of multiplication. 2 times 2 is 4. Okay? The next thing I have is I'm going to distribute it to this y down here. And this would be y. Now would I do 5 plus 2 or 5 times 2? Times 2. 5 times 2 is 10. You're multiplying. And then lastly, we have 2 raised to the power of 2. Remember, 2 squared, which is 4. So I'm going to have a 4 down here. Can I simplify anything further? No, because there aren't any like bases with each other. So just like if I had 3 to the 5th and I distribute, it's still going to be 3 to the 5th power and whatever that is. So you don't want to do 2 times 2. I know it ends up to be the same answer, but you want to be careful because, 3 times 2 and 3 squared are definitely not the same. So that is the